Welcome to today's Explainer. I am absolutely pumped you're tuning in because, wow, we are tackling a massive shift in how we build software today. We're going to completely demystify why AI-generated code breaks and, way more importantly, how you can fix it systematically. Trust me, if you've been experimenting with building apps using AI, you know the exact pain I'm talking about. Okay, let's dive right into this. Check out this stat. 25% of Y Combinator's winter 2025 startups have code bases that are 95% AI generated. That's a quarter of their latest batch. It's absolutely wild. We are literally living in a totally new era of development. But it also reveals a hidden truth that nobody really talks about when they post those flashy 10-second demo videos on social media. The truth? AI-generated code breaks. Like a lot. And here's why. AI doesn't write bad code because it's dumb. It writes bad code because you gave it incomplete context. That's the secret. Because so much of modern development relies on these models now, debugging AI output, it's no longer just a niche hobby for the early adopters. It's quickly becoming the single most essential skill you can have as a modern developer. To get you mastering this skill, here's our roadmap for today. We're hitting the AI coding trap, why AI code breaks, 5 common AI errors, the error-forward fix, AI versus manual debugging, and finally, preventing AI code bugs. Let's jump right in. Starting off with Section 1, the AI coding trap, or the reality of vibe coding. So if you have ridden the wild emotional roller coaster of modern app development, you are probably super familiar with the term vibe coding. Basically, it's building apps by describing the vibe or the goal of your project in plain English prompts instead of typing out all that complex syntax manually. And look, tools like Google AI Studio are incredible for this. You literally type in a prompt and the AI handles the heavy lifting. It writes the instructions, builds the UI, sets up the logic. But there's a massive catch here. The quality of that output relies entirely on the quality of your input. A vague request, you're going to get a generic and often entirely unusable result.
Let me know if this scenario sounds a little too familiar. Your AI just generated 200 lines of code, you push it to GitHub, you deploy it completely for free on platforms like Vercel or Render, you click that live link with excitement, and absolutely nothing works. The console is just screaming red text at you, the UI is totally blank. Or maybe worse, it looks perfectly fine, but it instantly crashes the very second you click a button. Welcome to the club. It's incredibly frustrating for sure, but your reaction shouldn't be to just throw in the towel. We actually have a very clear diagnostic roadmap to fix this whole shebang.
So the crucial point is understanding exactly why this happens. Moving to Section 2, why AI code breaks, which brings us to the junior dev analogy.
Think of it kind of like this. Asking an AI for code is exactly like asking a brand new, super eager junior developer to build something. If you just walk up to a junior dev and say, hey, build an av bar, what are you going to get? Well, you'll probably get something functional, but kind of weird. Right? It'll have the wrong colors, maybe they missed the mobile menu entirely, and it probably won't match your existing code style. AI is the exact same way. When you leave blanks in your prompt, the AI just fills them in with assumptions. And usually, well, those assumptions are dead wrong. All right, now that we know why it happens, let's actually diagnose the symptoms. Section 3, 5 common AI errors and what goes wrong most often. And this brilliantly illustrates the most frequent issues you're going to encounter. It usually boils down to 5 things. First up, import errors. The AI loves to just assume you have packages like FramerMotion installed when you totally don't. Second, type errors. It assumes your API returns an array, but wait, it's actually getting null. Third, React state bugs. You click, nothing happens, and the console gives you 0 errors. This is almost always missing state updates. Fourth, styling breaks. Sure, it looks pixel perfect on your big desktop monitor, but the AI completely forgot to add responsive Tailwind classes for mobile. And fifth, event handler fails. The AI writes a beautiful function, but completely forgets to actually pass it down as a prop. So how do we actually cure these headaches? Section 4, the error-forward fix, or how to let AI fix its own mess. Your universal debug prompt is actually incredibly simple. Try this. Fix this error, explain what caused it, and provide the corrected code. Instead of banging your head against the wall for hours trying to trace the bug yourself, you use this framework. But listen, you can't just paste the error text alone. You absolutely must give the AI complete context. Paste the exact error message, sure, but you also need to paste your full component code and just briefly explain what you are actually trying to do. We call this the 4-step error-forward loop. Step 1, copy the exact error. Step 2, copy the relevant code. Step 3, feed it all to the AI using that universal debug prompt we just talked about. And step 4, run the fixed code. This simple context engineering technique sounds honestly almost too easy, but it literally resolves about 80% of AI code bugs instantly. The AI is surprisingly great at fixing its own logic if you just hand it the full picture of the failure.
But what happens when that doesn't work? Let's get into Section 5, AI versus manual debugging, and knowing exactly when to step in.
Sometimes the AI will just get stuck in a loop. It'll endlessly generate the exact same broken fix over and over. When that happens, you really have to know your boundaries. Let the AI fix the annoying stuff, right? The import errors, typos, missing null checks, throwing in responsive classes. But you must step in and debug manually for things like security vulnerabilities or complex state logic, where you really need to understand the actual data flow, and definitely for performance optimizations. Rule of thumb, never blindly trust AI with authentication or user data code. Just don't do it.
Ultimately, the absolute best debugging strategy is preventative medicine, bringing us to Section 6, preventing AI code bugs by writing prompts for clean code.
What's really interesting is just how simple these preventative tweaks are. Don't just give it a prompt like build a navbar. Explicit constraints are what stop the AI from making wild guesses. Tell it exactly what your stack is, like say React 18 with Tailwind version 3. Specify that you want loading states and null checks handled up front. Provide examples of your data structures so the AI isn't just taking a stab in the dark at what your database looks like. And finally, use models that are actually built for this. Use Gemini Advanced or Claude, which have massive context windows and really strong reasoning capabilities for coding tasks.
Okay, and right before you launch that app you just vibe coded to the world, please use this pre-ship checklist. As you'll see, AI code loves to work perfectly in a happy path demo on your local machine and then completely explode the second it hits production. Just take 5 minutes. Ensure the build passes without any TypeScript errors. Check for a squeaky clean console. Actually open the app on a real physical mobile phone. Click every single button. Check your empty states when there's no data. I promise you, doing this 5-minute review is going to save you hours of debugging a live site while users are trying to access it.
I want to leave you with this final, somewhat provocative thought. Is debugging AI code just the new way we program? I mean, as developers, we are spending less and less time writing raw syntax and far more time engineering context, architecting solutions, and managing AI output. It's a fundamental shift in what it actually means to be a creator in tech today. Mastering this error-forward process isn't just about fixing bugs today. It's about future-proofing your entire career for tomorrow. Thank you so much for joining me on this explainer. Get out there, start prompting, and happy debugging.